SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Systems Technology Part 2 Module 10. We were talking about FMEA in the last module and we theoretically introduced the concept of FMEA. So we want to actually now start looking at a practical FMEA problem and how the analysis has been carried out in one of the automotive manufacturers in their paint shop. Okay. So let's now understand. So what I'm going to do here is to sort of look at this particular FMEA sheet, which you can see here in this particular slide. And we are going to understand this by some diagrammatic representation, which I am going to draw in the next slide, which is here, diagrams to understand the FMEA chart. Because there would be issues related to the process, you should have some understanding of what really the process is about. So I will do that and back and forth swipe between slide 1 and slide 2 to make you understand the various steps associated with the risk identification and how elimination has been done or what countermeasures have been suggested. So let's look at this process FMEA very closely. We are talking here about a potential failure mode effect analysis process, and the process function that is in this particular slide here, which is corresponding to column 9. This is obviously of a much higher size sheet which has other columns as well, but we are just making sure we are just concerned with only this part of the sheet which talks about the FMEA process actually. So the requirements here is the manual application of wax inside doors, okay, and the process function really is to cover the inner door lower surfaces at minimum wax thickness to retard the corrosion. So those of you who are not involved with an automotive assembly, I would just like to illustrate what really it means. So let's say we are talking about a door, okay, in this particular manner. So typically on a door you have the outline of the door given in this particular schematic cartoon, and from the inside it looks like this, okay. So the door typically is comprised of two different aspects. One is the door outer, okay, and the door inner, and obviously the door inner is basically this side, the one which is being shown top up here, where you can see the inner member having these perforations or holes, and it is really a certain amount of thickness. So the outer is on one particular side of the door and the inner is on another, and you are hemming the inner and outer with respect to each other with spot welding or whatever processes, and these cavities are created within the inner of the door to ensure that you have access to placing the various other sub-assemblies within this door, like let's say the window regulator, or let's say the guide channel called the sash for the window to be able to go up and down. So all these things are done through this inner side, and the mounting is given by the access provided on the inner side of the door. So obviously the purpose of the door inner is twofold. One is to actually create some kind of a bracketed component which can hold the various interior requirements of the car assembly, like the trim board, or maybe the window regulator handle, or in case of an auto window the power switch, so on and so forth. And the outer member obviously is the outer member which formulates a part of the body of the car, the outer body of the car, and typically there may or may not be a third member in between. Sometimes there is a placement of a third member in between here, which is used for the purpose of strengths, So therefore, there is one member on the outside, okay, which you are not able to see. It's on the rear side of this, okay. So that's the door outer member. And then there is the inside member, which we just talked about, okay, the perforated member. And this is somewhere in the center. You can call it a central beam, or it is something which is providing the strength to the door in some cases, in case of accidents, etc. And typically the way that the assembly happens is a weld assembly, where the outer and the inner and the center members are all put in a jig, and the hemming is done on the edges here. So there are spots related to doing the hemming in all these different regions, where these three sheets would be meeting together, and you can have welded spots in almost all these different areas, as you can see here in the door. So it's a very, very complex unit, and obviously the purpose, as you can understand here in the FMEA, is the application of wax inside the door, and to cover the inner door lower surfaces at minimum wax thickness to retard the corrosion. So the purpose here is, obviously when you have made the door outside and the door inside, you are able to somehow go inside these gaps into the space between the door inside and outside, and are able to apply wax in these particular areas or in this particular regions, to ensure that if supposing there is some kind of a splash, water splash, and obviously the door opens and closes many times, and it is accessed, it is quite accessible to the splashes of the water, etc., which comes out during the routine operations of the vehicle. So, or even during, let's say, rainy season, there is a problem that there is going to be a case where the automotive goes in a submerged manner, and a part of this door is already submerged in water, this kind of a level. So you have to ensure that even though there is a hemming between the inner and outer members, there is going to be some kind of a waxing in the inner member, which would prevent such a thing from happening. So the idea is that if this is the thickness, where this is the outer, this is the inner, you have to go from the inside, and in between the two you have to give the wax coating somewhere in the middle. So you basically, as I again told you, please understand this very carefully, this is the outer member, okay, as can be seen by the inner member, as can be seen by the shaded region, and you are going into the cavity of the inner member and going into that space which is formulated between the outer member and the inner member, and trying to do the wax coating. Very, very clearly I would like to define this here, okay. So you are talking about such a waxing process, which is typically done after the painting of the body, car body is done. Typically at the end of the paint shop, that this wax is somehow done in the system, so that you can keep it free of any rust or any other problems. So the problem that has been identified, or the potential failure mode that has been identified, which in fact creates rusting of the components, it's a very big problem, is that the wax coverage on a specified surface is not appropriate or is insufficient. So obviously you can see that it is very complex for an operator to sort of go inside all the way into this region, unless really he has a jig or a gun, okay, which can deliver the wax. But there is always a problem that the wax may not be able to sufficiently come and coat the inner surface of this particular door, so that there is a prevention of the water from entering inside the hemmings, etc., which are there. So it's a very difficult location, and obviously it is something which also has a very high chance of going undetected, because obviously in the assembly, when the car has gone into the assembly, or even let's say even at the paint shop stage when the waxing, etc., has been done, unless you are able to see, and seeing is also not very accessible here. You can see a problem where the you can think of it, whether the wax is covered or it's totally covering all the way to whatever region it should get into. With a manual visual kind of an inspection, it becomes very, very difficult to see whether inside this door, outer, inner, the wax is getting covered in the whole inner surface smoothly or not, okay. So it's definitely a defect which has a very difficult detectability, and obviously it is severe because it creates rust in the inner and outer members of the door, and that is a very you can say that the severity of this problem is quite high, And the occurrence also, it has been found, is quite reasonably high. And you know, you can say that the potential effects of this failure, so once this wax coverage is insufficient, the effects of this failure could be the deteriorated life of the door, which can lead to an unsatisfactory appearance due to rust through paint over time. So obviously there is going to be a sneaking in of the water within the door, inner and outer, and it's going to start rusting the inner side, inside of the door. Okay, and so there is an unsatisfactory appearance because of this rusting through the paint over the time. And then obviously the impaired function of the interior door hardware. You have window regulators, you have sashes, you have weather strips which are there on the door for this particular purpose, okay, so that there is no sneaking of water. Once the door is jammed to the main body of the car, there is obviously sufficient packing of rubber between the door and the body of the car so that the water may not go inside the car. Okay, but the idea here is that this can get impaired, the functionality of such systems like regulators, etc., because of the continuous splashing of water and going inside, may slowly get rusted, and because of which the functionality may slowly get reduced over time, and it can create a customer dissatisfaction, a customer negative point for the customer, and so obviously the rating of the vehicle, etc., can go down because of this. In fact, there can be a warranty issue, a major critical factor in the automotive, that the customer has to again and again go and get things repaired inside the door. Okay, and it may lead to a chain of other things in the process. For example, it may lead to the opening and closing of the trim boards again and again. It may lead to the mounting and taking out of things like regulators again and again, and it is not a very comfortable situation. Okay, so therefore it's actually creating a chain of different problems, just because of the simple problem of the wax insufficiently covering the gap between the inside and the outside to the of the door in this particular situation. So the severity of such a defect has been rated as 7, because obviously there is a chain of different problems which is associated with such a defect. And then let's now look at the potential causes or the mechanisms of the failure which has been identified here. So once the effect of the failure has been identified and the failure mode has been identified, okay, so one thing that I am very sure is that we are only working on one failure mode here, whereas the overall check sheet may have more than 30 different failure modes and 30 different potential effects of the failure. In the same manner, in a columnar manner, you will have to address the different modes and organize the different RPN values which are there. Now, when you are doing this, the potential causes or the mechanisms of the failures, you closely study on the paint shop line and see what are the different responsible reasons for why this wax coverage may not happen. So one of them is that the manually inserted spray head is not inserted enough. Obviously, when you are talking about a door subassembly, and you see here how difficult it is for the operator to actually take a wax nozzle, which may be otherwise, something like this, with probably a nozzle gun, and then you have some kind of a pipeline which is used by the operator, who probably holds the gun in this particular manner, okay, and inserts the gun into this gap right here. Okay, so you have a grip of the person, as you can see, over the nozzle. Okay, so this is how a gun really looks like. A wax gun really looks like. You have a feeder, a tube, where the wax is melted and flown at a certain temperature, and then there is the hold point for the gun. You can see this operator holding this gun at this particular place. It initiates the wax trigger, which pulls the pressurized wax from the tubing end, the feeding end, all the way to this nozzle. So this is the wax nozzle, and the dispensing happens at the end of this particular nozzle, okay, as the operator moves. So you have to consider the difficulty level which is there, that this nozzle actually needs to get inserted into this small space here, and the nozzle has to again be turned from this side to this side, so that the complete coverage on this particular region happens actually because of that. So it is a very, very difficult proposition. So that's one part of it, that is manually insert the spray head, and during that you feel that the spray head is not inserted far enough, because probably it is not the nozzle, the nozzle is able to not cover the whole area which is needed to be coated by this particular nozzle. The other process failure which causes this failure mode to come up can be spray heads clogged. You see, the wax feeder into the system can also get lower, I mean it can also solidify because temperature goes down, and there is no heating arrangement as such, which you can see here towards the tip of this nozzle. Once the nozzle actually has the heated up molten wax and the wax is dispensed, there is a tendency that this particular region, this orifice here, can be clogged, okay, because it doesn't have any heating mechanism, okay. So because of the clogged nozzle, again, even if the reach of the nozzle is to all the area, the dispensing may not be proper because it has been clogged. So viscosity too high may be one of the reasons, temperature too low is another, and then pressure too low is another. So these are the reasons why the spray heads would get clogged, and that may be a potential cause for the failure, which is the deteriorated life of the door, leading to unsatisfactory appearance due to rust through paint over time, etc. And then obviously the spray head deformed due to impact is another. So sometimes what the operators do, that in case the door is not opening, or even the door is probably maybe because of some reason where it needs hammering for the door to be set back in place, or some jig to be set back in place, instead of the unavailability of a hammer, because of the unavailability of the hammer around the operator, he uses the nozzle head as a hammer, okay, sometimes, and that can create a problem of the orifice getting smaller, and again this insufficient dispensing of the wax from the tip of the particular wax nozzle, okay. And then obviously spray time insufficient is another, that you don't give it enough time, the operator, it's an assembly line of cars which is moving, and obviously the waxing is also to be done at that particular rate. So the takt time of a line is something like about 2 minutes or 2.5 minutes, so you have to do all the operations associated with that particular station, including the wax application, and that may not be given enough priority by the operator, because obviously it is inside the area and it may go undetected, but again it creates severe problems or severe impacts on the overall quality. So these are some of the potential failure mechanisms which are identified here, and based on that the occurrence of these failure mechanisms contributing to the final failure, okay, is being rated here. So the case of manual inserted spray head not inserted far enough so that the whole area can be coated occurs more. So that's probably one of the more potential reasons, and on a 0 to 10 scale, the concerned engineer at that particular process level has rated the occurrence to be at 8. So therefore in 80% of the cases, the reason why this failure of the deteriorated life of the door occurs is because the spray head is not able to go as far into between the door inner and outer, okay, and that's why it's a high level of occurrence. Similarly, it's about 50% of the times it is basically the spray head clogged because of the viscosity of the wax being too high, or the temperature too low, or the pressure too low. The pressures and temperatures, obviously, again let's look back into this wax dispensing system, is related to this end of the spectrum. So obviously the wax has to be melted to a certain level so that you have a viscosity low enough so that flowability can increase, etc. Also it has to be done at a certain temperature condition, and maybe because of non-compliance of those temperature conditions and viscosity conditions, the wax which is coming into the nozzle may not be to the level, may not be melted to the level that it is supposed to be, and it starts clogging the nozzle. So there is about 50% occurrence, and so the engineer rates that to be about 5. Okay, and then obviously spray head deformed due to impact is quite less in maybe 2 of the case, or 20% of the cases. The operator may have accidentally rammed the nozzle against something to do some hammering action, which may have resulted. In this particular case, the hammering action may be just related to the door getting jammed, and you have to open the door in order to do this application. So there he may have used this process, okay, because it's coming from the last step of the paint step, last paint step, where there is a possibility of sticking of the door with the body. So he uses this nozzle, and that creates a damage on the nozzle, but that's very rare. Okay, and then again, the spray time insufficient because of a change of operator also is very high. It's about rated 80% or so. So you have rated the severity, you have rated the occurrence. I'm going to probably close on this module in the interest of time, but in the next module I'm going to take up how you will rate the detectability of these problems, and then we will see what positive countermeasures can be implemented, and then again do the RPN analysis to see is the failure mode effect analysis good or bad. Okay, thank you so much.